All right, so we've got a model, we've interpreted our model, but let's kind of go back and revisit RSS, which recall is the residual sum of squares. So this is the statistic that is used to identify what that best fit line is. Now, if we wanted to actually kind of recompute the RSS, or the sum squared errors, we could do that, right? And so this code, we saw this actually in the last module, or at least parts of this, where we can take our model object and then we can use that to make predictions. So here we're going to make predictions on the training data. And we combine that with the original training data. Now what we can do is here, we just follow that, and we are selecting our predictor variable, our response variable, and then the predicted values that come from this predict function here. So now what we have is we have our predictor variable and the value for that given house. We have the sale price for that house, and then we have the predicted value from our regression model. Now we can use that information to compute the residual, right? So if you remember earlier on, we saw the visualization where we had the actual value, sale price of a home, and then we have the blue best fit line, which is a predicted value. And the difference, right, between those two represents our residual, our error. So we can compute that, which is what I do here. I mutate, create residual, and the residual is sale price, the actual sale price minus the predicted value. So now we get the error, the residual for each individual home. Well, what our RSS statistic is actually doing is it's going to go ahead and take that residual and we square it, right? So we could compute that using mutate. We compute a new variable called squared residuals that is just simply the residual squared. And then what I'm going to do, I'm going to summarize that. I'm going to have sum of squared residuals, and that's going to be the sum of all these squared errors. And we get our statistic. All right, so that's great. Luckily, R takes care of all this behind the scenes, and we really don't use this statistic when we care about using a model for prediction. But this is how that best fit line is being produced. But what we really care about is how well is our model going to generalize to unseen data, right? We talked about this in the last module. So we can go ahead and compute this just like we did in the last module, where we take our model object. We can use that to make predictions on our test data. And then what we're going to do here, we actually bind our predicted values with the actual test data. And then I use the RMSE function to compare the actual sale price from the estimates or the predicted values. And it will go ahead and compute the RMSE. So now we see my RMSE that is computed on our test data is $55,942. Right? So what this means is, on average, our linear regression model mispredicts the sale price of a home by about $55,942. That is what this RMSE, when we use it on the test data, this is what we consider the generalization error, and this is how we interpret that error.